Well, thank you everyone so much for joining another Balerion Space Ventures podcast. It's July 6th, and today I'm joined with Bianca Cefalo, the founder and CEO of SpaceDOTS. Bianca, it's so fantastic to have you. Thank you for joining us.
Well, likewise, I'm really excited about this conversation, Aidan.
So, maybe to start high level, you can give us an overview of SpaceDOTS, someone who hasn't heard of it before. What are you guys building right now?
So what I used to say about SpaceDOTS is that we are making invisible space threats predictable. And what do I mean about that? So if you look at the usual category of space domain awareness or space situational awareness, most of it is specifically at the moment focusing on tracking objects. Whether there are, again, anthropogenic objects, smaller objects, bigger satellites, hostile objects. But then there is something that I've always found extremely fascinating. As being a thermal engineer, I've worked with the environment of space itself. And something also more insidious, which you don't really see, which is the invisible. By invisible, I obviously mean the environment of each orbital regime. By environment, this is both the RF spectrum and obviously the space weather. So everything that's happening on different orbital regimes, and how that in itself is one of the harshest threats for anything that goes to space. From obviously, choosing any components that you want to design your spacecraft with, to operational in space, being at the mercy of the dynamic solar flares or anything that's happening with the sun, but also at something that, again, I find more insidious, which is electronic warfare or cyber threats that can mimic what the space environment does onto a subcomponent or to a system. And so what SpaceDOTS is looking at is pretty much in understanding the environment, so collecting, detecting more of what the environment of each orbital regime is, and how to correlate anomalies and any from the minor to major failures that are happening on systems or space-based services provided by the systems from space, how they correlate with a hostile intent or anything that has nothing to do with the natural impact of the environment. The first part is the attribution problem, but then as we move towards having more in-situ data, more cross-correlation with open source data, GNSS receiver, everything that is available or even that is classified, then we'll be able to start predicting what can potentially be a threshold of a natural versus an adversarial interference in space or to a signal coming from a satellite. So that's in a nutshell the problem that we're looking at.
Wow, fascinating. What were some of the specific moments or insights that made you realize that this is a problem that you need to go after and others have missed it and you thought you had the best solution driving you to start SpaceDOTS?
It's definitely being, let's say, a non-linear journey to even understanding or going about this specific niche that I would say that I even call it space environmental intelligence as part of the space domain awareness, which at the moment doesn't fully exist. So starting with my background, I'm an astronautical engineer by background. So I've been in the industry for now 16 years. Specifically, I started as aerothermal fluid dynamic analyst on Martian mission. So I worked on a payload that the German Space Center was developing for the NASA JPL InSight Mars mission, which eventually went on Mars in 2018. And that was the very first project I did as I was just out of uni, which was extremely exciting, but also very challenging. And having to be able to reproduce the environment of the Martian atmosphere to really understand how to design and operate the payloads on the Martian atmosphere was something that I thought was difficult by default because you don't really go to Mars on a daily basis, or at least not yet. So obviously, I didn't think it was going to be extremely easy for us to understand how the environment of a planet or the interplanetary travel was going to impact certain systems. But then as I then moved from aerothermal fluid dynamics to thermal engineering and working mainly on subcomponents and small sats on a low Earth orbit, and then as a product manager on telecommunication spacecraft for Airbus Defence and Space, I started understanding the real issue of the environment. I used to say that the environment of space in itself, especially for a thermal engineer, is the biggest nightmare. You have to start simulating, designing, correlating performance between what's happening in space with what you've simulated, seeing that most of it doesn't match sort of the performance that you were assuming isn't really the one that you were seeing in space. And the more I was moving orbits from LEO to the geostationary with telecommunication spacecraft, the more I was also realizing that a lot of the conservative design or over engineering that goes into certain national security assets, considering we were mainly selling to defense customers or government, is due to the fact that obviously this mission of a telecommunication spacecraft needs to last for at least 10 years, let's say. Most of them go over that lifetime. And most of the disruptions that are happening to these services, which are necessary for critical infrastructure and our life on Earth, in most cases weren't just disrupted by radiation or space weather or faulty components, but this interference was not benign. And so out of this frustration, out of the fact that I then moving from something super deep space to then defense, telecommunication, and then also working with suppliers of advanced thermal solutions to the space and defense industry, I realized that the environment of space in itself and whatever happens in there, which is pretty much dynamic and really unmeasured, impacts the entire value chain. From how you qualify something for the space environment, how you operate a system, how you are really making sure that everything that you have in space keeps being safe and secure and working according to what you thought you were going to see. So SpaceDOTS was born out of that frustration, out of the frustration of how the environment really impacts everything that you design in space. Then going more and more into this journey, as any startup, we are at a pre-series A stage, so we call it early stage. You go on a journey of understanding better the market, different markets that you can sell to. What's the demand? What's even the biggest problem amongst what your solution is? And so I started digging more and more into how kind of impossible at the moment, or kind of really underserved at the moment, is the problem of how do you distinguish between something natural that has happened as a failure, and how do you distinguish what is happening with the electronic warfare, its cyber threats. And the more I was digging in, the more I realized that many other also people have come up with the same issues and the same problem, solving it from different angles or adjacent angles, but how the environment of space itself also is the foundation layer of space domain awareness. If you're tracking objects, but you don't know how the drag affects the position of the object, then even your own algorithms for identifying certain objects may not be correct. If you are a high frequency trading financial institution, you are not insured against the acts of gods, so space weather. You also have a very thin insurance against state provided, let's say, electronic warfare. And this is because it's kind of extremely difficult right now to identify where the source of the disruption is coming from and how to distinguish that. So if you want to even think about the financial markets, when you're losing microseconds latency on transactions on a daily basis, you may lose hundreds of millions just because you don't know if that disruption of the GPS or GNSS has been due to space weather. So you're not insured, you've lost all your assets on that day or those microseconds. Or if it is cyber threats or electronic warfare, you may not be insured, so you don't get the money back just because it's impossible to identify the source of that problem. And so I thought, this is crazy. It was crazy for me to design and simulate performance of spacecrafts, not knowing what the environment was. So in most cases, thermal engineering is a bit of a magic box. But it's crazy to me to think that it affects so many other industries on ground, where you can literally lose hundreds of millions a day because microseconds were lost on a disrupted signal. just because the location of this issue is not being provided right now.
Yeah. And to help us get more of a concrete idea, what does it look like, these threats to a satellite with electronic cyber warfare? And, what can really happen to them? What might that action look like? And what are the countermeasures? How do you predict it and how do you react?
I can talk about one of the issues, which is the one that we're focusing on with our second assets in space and also our platform, our SaaS platform right now, which is, for example, if you consider GNSS disruption, and if you consider how that impacts components or anyway your systems in space, called ionospheric scintillation. This happens during a solar event in space. The same symptom of ionospheric scintillation is jamming. So your component would see what is called loss of lock. So basically, you have a disturbance on the radio frequency interference of your GNSS signal, which can be caused in the same way and giving the same symptoms of a solar flare or a jamming system. And obviously, when you lose GNSS, you lost any other track of that signal that was supposed to work on ground. One of the very examples that I tend to use right now on how this obviously is a domino effect on the ground is what happened in May 2024. May 2024, there was one of the highest solar activities that we've seen, something called the Gannon storm. During that particular time, also Starlink was aiding the operations during the war in Ukraine. And at that time, most of the satellites were losing, or anyway, they had interference signals on the ground to communicate with the operations on ground due to the solar storm. Now, on top of that, what's been then reconsidered months or weeks later of forensic and analysis is that compounding on the loss of signal due to that solar storm was also electronic warfare from the Russians. This compounded into one single disruptions of the signal, and obviously everything else was halted, from the operations during the war to everything else that was happening in Ukraine. And this happens more often than not. What obviously is difficult to say or understand is that certain events are so particular that operators would not tend to publicize what has happened. And so the idea of using SpaceDOTS solution is that to be able to provide in hours and not weeks or months of post-action, post-forensic, that distinction between was this ionospheric scintillation, was this electronic warfare or jamming, and how to identify the compounding effect of the two. If one is hiding behind, it was a solar flare, what can we do about this? That's really the deceptive element of this problem.
Got it. And how do you think about the total addressable market here? Are you tied to the amount of satellites that are in orbit, or is this more about the value per asset, per satellite?
At the moment, considering that we're gaining a lot more traction from insurance and parametric insurance, what we're seeing is especially the value created, or anyway, the value added for understanding how you keep alive and safe the services coming from the satellites rather than the asset itself. Although obviously when you are, and this is more for the, let's say, downstream application. For the upstream applications, it's really about safer operations. It's really about, again, understanding a lot faster, attributing a lot faster what kind of failures and, let's say, faults have happened on your components and what you can do about them. For example, if you think that your systems have gone down because of a solar storm, but actually that wasn't the case, probably you can improve your uptime. You can improve also how you're operating in rendezvous and proximity operations, because in those cases, if there is something or some actor coming too much close to you, how are you going to distinguish that you're going to be non-kinetically attacked before being kinetically attacked? That's also one of the deception that they use. They get very, very close to your satellite and your asset. They don't do anything, but they may do jamming and spoofing. And so this is the value added to that specific operation.
Got it. Yeah. And yeah, those operations, it's getting, a lot more satellites going up into orbit. We've seen exponential growth over the past 3 to 5 years. And so I'm wondering, 3 to 5 years in the future, how we're really going to be able to manage so many satellites in low Earth orbit. And with more advanced technologies and systems there, I'm curious what really needs to change to make it operate smoothly and securely. Because, these satellites, there's satellites that are very old, there's satellites that are very new. They keep growing and becoming more advanced. And I'm wondering what that next iteration will be that changes everything. 'Cause it seems to keep happening, and what we need to do to keep up with this pace.
Yeah, it's what's going to happen in the next years is crazy, considering orbital data centers and it's also not just on the low Earth orbit. What you could see growth on MEO, GEO, and the cislunar, which is even less characterized or used by anybody. I think in general, what should need happening right now is that, and what I see also across the board, especially when it comes to security and resilience, is having neutral, independent third parties where you can trust that the data that you are sharing is actually providing a service to you. Why do I say that? I say that because, for example, if you think about SpaceX, SpaceX is now the biggest name in space. And they are fully vertically integrated, and they will be even more integrated with loads of other stuff that they're going to do. But for example, when they come out with something called Stargaze for space domain awareness, or better, SSA, so understanding out of tens of thousands of radar data where the objects are and how to avoid them and how to ping them, what happened is that a lot of operators started stopping trusting that layer of situational awareness because it's biased towards, obviously, SpaceX, rather than be something neutral that other nations and other operators can use. So I think the more, obviously, there is a monopoly in space, the more the trust between the operators and the nations is going to have a bit of a shake, because at the moment nobody trusts each other with data, which sharing data of where we are, what's happening around any asset and so on, it's the biggest thing that should happen for any coalition. And I mean NATO, Five Eyes, all the allies, the states. But at the moment, in the first place, this kind of framework of sharing data and understanding how the space itself is affecting everybody in the coalition, it's not really there. There isn't really much of a framework of understanding how can we trust our allies if maybe even our allies can, come up to us and do something against us. So it's the space environment has just become extremely geopolitical. And the same frameworks that are now being used for geopolitical tension or peace on ground will have to be used in space, but hopefully learning the lessons that we've learned on ground without, producing the same effects in space. So I think the level of trust between nations, instead of caging or instead of, competing with each other when it comes to national security and safety, there should be a lot more sharing of data and information across the coalition. I think that's the first thing we have to do. Otherwise, there will be always one player or the other player doing everything that they want onto an orbital regime and leaving little space or nothing for everybody to come next.
Yeah. And you've had some solid traction so far. Your company being early stage, you still have sent something into space. Can you tell us a little bit about that? What exactly did you send to space? What would it look like if someone were just be staring at it? And,
Yeah.
you know, what operations did it run to show demonstration and prove out your system? And I guess what next?
Yes, great question. So what we've sent up now, we called our sensing capabilities data dots. They are Alpha U payloads crammed with sensing capabilities. The first one that's gone up was in January 2025. It was obviously an MVP. So that was meant to prove our operations, the fact that we could actually operate in space for more than 1 year, which we have. Being able also to retrieve that data, package that data into the API. So it was the whole cycle: space mission, API evaluation, and then aggregation of that data with open source data into our SaaS platform called SkyEye. All of these happened in the past year and a half. So we had to make sure that we could do the entire end-to-end process. The second mission, Data.2, is going up in October. This one has dual use sensors and it has GNSS, dual band GNSS receivers with multiple others that are characterizing in a way that's more complex and refined the environment around the spacecraft that's hosting us. And fingers crossed, everything goes well, this will be the first actual asset in space where we will be able to start providing in situ attribution of ionospheric scintillation versus jamming. This is obviously the goal, the milestone that we have with this second payload as soon as it's operating in space. But beyond that, obviously that data is incorporated into SkyEye. It's benchmarked against open source data. This benchmarking is going on. It's providing scoring against anomalies that are still ambiguous, adversarial, technical. So this is where we are at the moment. We are addressing specifically parametric insurance, but also the space commands. In fact, we are in chat with UK MOD. We have their support with Space Force as well, with Italian MOD too. And this is because it's becoming obviously a national security imperative to really understand the security of your assets in space. But what comes next is moving away from the low Earth orbit and start to reach orbital regimes that are critically undermeasured and also going to be a lot more used. So having a payload attached to a spacecraft is extremely useful because you have low capex. You also have lower risks if anything happens while still keeping your mission alive. But what needs to happen next is more coverage. So we are working through a development roadmap, which is while we increase the data that we are aggregating towards our own platform, and we start also having attribution algorithms running on the ground, we will want to move towards independent constellation of small sats. And to do that, we want to start also building in-orbit AI and software so that we can start understanding or filtering directly from space what can happen on an asset, what's happening in space, and providing triggers that can then be used by other operators without them necessarily going through a SaaS subscription. So that's the step change that we want to make. We want to create an intelligence mesh across different orbits whereby the edge compute and the AI directly from space will be able to trigger that warning, and eventually by inferring all the telemetry from space and the environment of space itself, start preventing directly what's going to happen rather than just say it happened now, this is what happened, this is why, this was the actor, and what to do next. So by covering more orbital with Edge AI, we will just the reaction to the problem.
Got it. Okay. I think you cut out there a little bit at the end.
Oh,
just like that last 15 seconds. Could you go back on that just so I can?
Okay. Oh, I'll have to remember where I was. Okay. What I wanted to say was that being able, so again, long-term vision, being able to have a higher coverage of different orbital regimes with Edge AI. At that point, we will be able to prevent the issues and not just provide the action or the post reaction to what has happened. So that's again the long-term vision. We're starting with detection and attribution right now with first payloads and the SaaS platform, moving to prevention as soon as we will have developed technology that can do that directly from space rather than from the ground.
Got it. Okay. Now, this is great traction that you've had, and you're an early company, and it's a company based in the UK. Is it based in Italy? Remind me again.
It's based in London. So officially, we are a Delaware C Corp,
Okay.
which is extremely useful for many reasons. But we were born in London and flipped to Delaware when we started raising funds.
That's incredible. And, a lot of these European space tech companies, they have, more trouble than, say, a US space tech company with raising capital, getting that traction, being able to put something into orbit. It seems like it takes so long a lot of the times with the European companies. You've been able to do this quite fast. I'm curious, what is your secret? How are you able to form this idea and get something built and into space so quickly? And now, a second flight scheduled in October. What have you been able to do there to help you navigate this environment that usually takes a lot of founders much longer?
Yeah, I would say that I think one pro towards Europe and the UK is that I would say that the ambition of the founders in this space in the UK and Europe is equal, if not sometimes more than any other founders. Just because you have to work with very constrained funding and very conservative mindset. So I think this is part of the fact of a founder journey where somehow you have to compete with a lot of amazing people out there. So you either have to make it happen or you have to make it happen. I think that's just the first mindset that you need to have. The other one I would say is that having had an experience. So I worked whilst I was starting SpaceDOTS. I was a sales executive for a scale up in the States, in Atlanta. And so that exposure to, going from a Series A to a Series B with a US startup started to definitely help me out understanding the level of pace and the level of, network and how you have to go about certain conversation with investors, fundraising, commercial pipeline, all of that. So I have to say that having had that experience clearly made me understand what urgency means in the US terms versus what urgency is in European and UK standards. Also, having done a Delaware C Corp flip at the exact beginning where we were fundraising for our pre-seed round, was also extremely useful to us. Because in fact, most of our cap table is US based. Our pre-seed was led by Boost VC in the Silicon Valley, the second one from Film Founders Fund out of New York. So having had the chance to pitch on the bigger vision rather than just on the conservative KPIs, let's say, that you want to say in Europe, because I had seen that happen while scaling a company from Series A to Series B, definitely helped me out in understanding we don't have to think just locally. Space cannot be local. It has to be universal, basically. So give me a chance to approach the States, the customers there, the way to even pitch an American investor in a way that was obviously more relatable to them.
Got it. And beyond working with investors in the US, have you been working with government agencies in the US as well, and also Europe? I'm curious because I'm sure both of them want these services, what that's been like and how you sort of navigate those landscapes, whether it's a government service from ESA or, the Department of War, if I don't know if you've been talking to them much.
Yeah. So there is a limit that you reach by not being an American founder. I was actually having a conversation with an investor before, where obviously I was asking for help in this kind of context. Because, for example, if you think about Space Force and the DoD, for example, they had an RFI beginning of this year that was literally about environmental monitoring, and a lot of the needs that they were identifying was the needs that SpaceDOTS is filling. We were able to respond to the RFI because it was open to, especially because we could use SpaceDOTS Inc. as a Delaware C Corp. But when now a proposal comes out, what can happen with us? We could only be a subcontractor. We couldn't be a prime because I'm not American, although the company is in Delaware. And so there is to be a workaround this, like having a proxy board or having some other institution there that's helping you out with writing a grant, winning a grant, being able to lobby, where sometimes I couldn't even be in certain rooms because I don't have the security clearance for me to be in certain rooms. So at this point, it's really surrounding yourself with the right people in the right places. When it comes to the UK or Europe in general, I would say this has been easier in terms of having certain conversations and moving them along. Although even we're now going to be live on the global data marketplace, which is run by BlueStack to sell data for the space domain awareness users. We managed anyway to have a sponsorship by Space Force. And because, I had to leverage my own personal connection, whereby they said, okay, we're sponsoring you to get there. So you can get quite far by having the right network. Where you're going to be stopped is when you have to win something and you don't have security clearance and you have to work with the government and you are not American. So that's what's going to stop us. When it comes to Europe, for example, we won a contract, an award from the European Space Agency that we're still running. Again, it's based on low SWAP environmental monitoring. We're being supported by the space weather community there. So this is a lot easier for us being the thing fully European. The same with the UK MOD conversation that you can have with the Space Command and support that they can also sign for you. It's easier to get because it's NATO. But for instance, one fun part is that by talking with the Italian Air Force, and so the Italian MOD, although I'm Italian as a founder, because the company is not operating fully in Italy, there is a problem of being able to provide a service as a sovereignty kind of services. So there are many kind of boundaries around what you can do based on your citizenship and based on the location of where you are, and you have to work around them. And this is what I'm trying to do right now.
Got it. Yeah. And yeah, the context I'm wondering is like, if they're using your service at that point, who really owns the operational platform picture of SpaceDOTS? Especially when satellites belong to different nations, companies. Like if you were to sell this or have this service on, a U.S. company's commercial satellite, and they wanted to work with the government on higher level things, would that be okay, or is there still sort of this gray area?
I would say that if we're purely data provider, in that case, if the data this is what we're really working at right now. Because if you think about going to the subscription to a platform that's providing insights to you, then by default, you will have your own personal accounts, or whether you are a spacecraft operator in Europe or in India or wherever else, you can just access the information that you need to access to. The same with us being hosted on other platform right now. So there isn't an issue there. But when it comes to data, for example, when we're looking at the UK MOD, there is this concept that has to be nationally separable. So if the data has been produced by UK produced asset, then obviously that is sovereign data that goes into a UK system. How do I give the same data to Italy or the US or Belgium? It's something that we're working out. We're trying to understand where the boundary lies between if we detect even something that has gone against one national security asset that we've been tracking or working with. I asked this question to a NATO community day a few months ago. Where does my responsibility end as a private company if I see that there is an attack towards your asset and all I can do is distinguish it and detect it? Where does the action lie? Is it because the company is in the UK or US? Does the responsibility is on the US or the UK? If the asset is, where does it lie? And nobody had an answer. it's all very muddled.
Yeah, it's so new, and a lot of things are still being figured out along the way,
Yes.
especially with this incredibly fast, rapid development we're seeing in the space tech industry alone, and how many satellites are going up. So as we move towards that, future with everything scaling up so fast, what do you think is going to happen to where this service, what SpaceDOTS is doing, is just required? Like, it just has to be on satellites. They have to know this. You mentioned earlier with Starlink satellites issues they had in 2024, I believe. Uh, those issues, are they gonna start happening more just because things start moving around and there might be more conflict with adversaries in space, or will it just become, there's so many satellites, it's, we gotta be able to detect the weather and everything. I'm wondering what the main driving factor for a future of space dots being just needed is.
Yeah, I think it's the convergence of both aspects. So where the space economy is going or the technology is going, because now everything that we do on a daily basis is depending on signals coming from space or from satellites. So by default, any source, the dependence, the interdependence between our life and space, space signals and space assets is going to be more and more the more we just move on, especially if we are thinking again orbital data centers or more commercial space stations or any manufacturing in space, moving towards lunar habitats and then going to Mars. So the more we're fast forwarding our life depending on space, the more you have to be careful about everything that's happening in space and everything that's happening in space, because there is a lot of geopolitical interest, obviously, on how the space is becoming the fourth domain of fight and war and battle. All of these disruptions, I remember even 2 years, like if not the beginning of last year, I was advised not to talk too much about these disruptions in space because there was a bit of like fear mongering or whatever, or I was not allowed to talk about all of this. Now, if you read everywhere, somebody is being chased by a hostile satellite. GNSS, spoofing, jamming is everywhere. Cyber threats are now coming more and more onto the case. Space commands, both from the US or UK or Germany, they've all been dispatching reports about how much the environment of space is becoming extremely contested and congested. These are like the two most used words nowadays when we talk about space economy, and how much of that is still used as a deceptive environment because it's not well known what's happening in there. So I would say it's the convergence of space is now becoming indistinguishable from everything that we do on Earth, and it's going to become more and more. But also because of that growth and because of that interest that different states, different nations have in space, the space dominance, who knows better, who knows more, and all this sort of deception are now becoming a daily conversation. And that's why it's indispensable that space does exist. Obviously, I'm very biased, but that's pretty much where the industry is going.
Yeah, and you know, how do threats differ from something in low Earth orbit to something in, you know, geo, much further away from Earth? Are the threats, similar, or do they have to approach, you know, threats in a much different way with maybe higher radiation, things just being farther away, latency issues, connectivity, all that sort of things?
Yeah, so purely speaking about the environment, clearly the radiation environment is extremely different. For example, in low Earth orbit, you have also certain elements called atomic oxygen that you don't have on a geostationary orbit. So the environment itself and how it impacts your systems and subsystem is very, very different. On a geostationary orbit, radiation is a lot higher. It's of a different type, but also on a geostationary orbit, you have different assets, telecommunication assets, defense and national security assets. Most of them, if not all of them, are sitting in GEO rather than LEO. Obviously, now it's a bit shifting because LEO is becoming, even MEO is extremely different. So that's really the distinction between LEO is now the one orbit that's commercially used by everything. If you think about geostationary, this is where I worked on those telecommunication spacecraft with Airbus Defence and Space, and they are the ones who are sold to the Turkish government, the national security, these, and that. So not only you have a more dynamic and different natural environment, but you also have a different operating environment in terms of how important it is, that environment, for certain actions from a state, which obviously makes it more and more, let's say, attackable in a way, or prone to be attacked just because certain assets are supposed to be there for certain services.
Yeah. What do you think some of the most important assets in space are right now, and what will be some of the most important, 3 to 5 years from now?
Mm. Uh, One thing that I'm really looking forward to is really how do they make orbital data centers? I'm curious. I'm very well aware of the thermal challenges and the skepticism around them. But I would say that the most exciting part for me is that, and then space factories. I would love to see an entire, supply chain being placed in space, so that then we can move on to the next, let's say, planetary object, which is the moon, and then from the moon going to Mars. So I would really love to see how certain aspects of our supply chain moves to space. That's the first thing that needs to happen so that we can actually use the environment of space for the next level, let's say, of humanity.
Yeah, I think it's really cool. And, thinking about that future of things just getting congested with more and more satellites going up, um, the threats grow higher and higher, whether, you want to look at it from adversaries, just having more targets, harder to track. Domain situation up there gets a little tricky to, things like the Kessler effect of what if these
Yeah.
things run into each other and send off debris, and that just starts a chain reaction. So, yeah, that kind of future. Uh, I'm wondering, beyond being able to sense and use all that data to create informative decisions to avoid that, what other measures beyond that come into play, whether it's space robotics or satellites to capture debris or work with taking out satellites that are defective. The next step of knowing the threats, knowing when you're in trouble, how you're going to actually move into action. What's that next step?
Um, I would think, or again, that's again going more into the utopian aspect of space and having people living fully in space. We've seen with the International Space Station now for the past 20 plus years, we've always had humans in space, but that was very much limited to the fact of doing science in space. When we're going to move to have humans actually living in space or even being born in space, which is the next amazing thing that I would love to see. In that case, understanding and monitoring and avoiding threats from space, it becomes a life or death situation. That's pretty much what happens at that point. It's not just about providing those triggers or preventing them. It's fully monitoring the life cycle of the space station, fully monitoring how your life is going to progress in space, just not for a couple of months, but for years. And again, in environments where we actually want to have settlements or habitats like the moon. It depends also on the different philosophies. There is one philosophy of having settlements on the moon and then on Mars, or having the whole concept of the O'Neill cylinders. So like fully self-sufficient microgravity environments where you can have pretty much the life or reproduce the life that we have on Earth onto those. Whatever is the direction that humanity or we as technologists want to take for humanity next, understanding those threats at this point is not just about one component that has gone faulty or one financial transaction that hasn't gone through. It's about making sure that the next generations of spacefaring humans are actually going to stay alive and reproduce there. That's the more sci-fi vision where I look at.
No. And if as these problems just become more imminent, like it's going to happen as it grows, and there's other companies that maybe want to understand these threats and they want to create something that's similar to SpaceDOTS or ride your coattail and create a competitive company. What kind of issues are they going to realize very quickly uh, if they were to try to recreate what you've built?
Um, One point is obviously the knowledge of this specific topic, and I say this because when I talk about the problem that we're particularly solving, everybody says it's a problem that exists, but it's also a very niche problem. It's a bit like the signal intelligence problem, which was just used or solved by the government or defense, and then Hawkeye 360 came about and made it commercial. It's very niche, so it's something that first of all you want to have to like, because it's not as sexy as rockets and big commercial space stations or a big constellation or big sats. So there is also the element of its niche is a bit unsexy towards all the other stuff, and you really require some specific understanding of what you are building because of how niche it is. And then the other problem that I would say is something that I've also learned, and I think every founder learns throughout the development of their business in space specifically, is that space at the end of the day is a very small industry. Although we do big stuff, it's very small, and as much as fundraising. So it's all about the people that you know. So if you know a lot of people that can pull a lot of capital for you fast enough, you can start building something, but then you have to have the knowledge. So having both of them together, I think, is the biggest challenge that we're also facing, because you get from one stage to the other one, and at the end, your network and your knowledge have gone to a certain level, but then you have to level up, because now you need more network, you need more influence, you need more, lobbying here and there. So I always say building in space tech or defense tech or dual use is a lot more about becoming. I'm a technical founder, so I once was an engineer, now I'm a salesperson, and I need to sell this vision to everybody. So you need to understand how politics work, how the geopolitical environment works. You need to know a lot more about that and the technology that you are building, and then eventually you can go and build it. So it's kind of hard.
Yeah, it sounds like a bit of a puzzle there.
It really is.
So, Bianca, if there's someone who's listening to our conversation and you wanted them to walk away with one big takeaway from what they've learned from our discussion, what would you want that to be?
Mm, hmm. I would say that I will go along the niche problem. And I would say this because I was told multiple times that everything I studied or whatever I was doing since I was at uni was niche, that I would have never found a job. I would just say something that, especially in the space industry, first of all, there is so much opportunity out there. Even if you are not part of the space industry, but you have found a solution for a very niche problem that you exactly know and you have solved for something or someone else or yourself for any other market on Earth, be assured that that problem is going to need solving in space. So I would say this: if you are very good at one niche, you have the knowledge, you have the passion, and you think that that same problem exists in space or defense or dual use or the future of the space economy, rest assured that it will, and it will need solving. So if you're thinking about starting something in space, this is the right time. It's hard. It's extremely challenging. Like any other founder would say, being a founder and building something in deep tech is extremely challenging, but also very rewarding. And the problems that will need solving for the space industry and the space economy as a whole will be immense. So if you're thinking about starting something right now, look at your niche, look what you're good at, who do you know in the industry, latch on to that and start.
Well said. Well, Bianca, I want to thank you so much for taking the time to join us today. It's been a fantastic conversation, and I'm really excited to see the future progress and milestones that SpaceDOTS hits.
Thank you, Aidan. It's been my pleasure.
Absolutely. Bye. Take care.
Bye.